2 of the revision notes. I'm just going to go over it really quickly. Hopefully, I'll be done soon. So this is sectors chapter 4F here, okay? So a sector is made up of two radii. So radii is just a plural form of radius. And then you have the curve between the two radii, okay? Now, what you will need is you need two things, okay? So you need the angle of the sector in degrees. So this angle here, this angle is the inside angle, okay? So you need the inside angle of a sector and you need the radius of the circle, okay? This is the formula here. So you have area of sector equals angle over 360 times pi r squared. Now remember, pi r squared is just pi times r squared. And what we're talking about, the inside angle here, is this highlighted in red, okay? That's all you need. So let's just go through the examples. So find the area of this sector, correct the two decimal places. So I have my angle being 120 degrees. And then I have my radius is 2 centimeters. So let's just write down our formula first. And now when you substitute stuff in, I2 squared, if you type that in your calculator, so 120 over 360 times pi 2 squared, you end up with 4 pi over 3. And then if you write that into decimal places, it's 4.19, okay? So 4.19 centimeters squared, just like that. Let's have a look at the second example here. I've given 5 meters as a radius, but this is 70 degrees here. Now, as you can see here, the 70 degrees is the outside angle. Now, to find the inside angle, you need to find this red part here. That's the angle that you want, okay? So to find the inside angle, you would just do 360 minus 70, which is 290. And that's the angle that we'll be using to find the area of the sector, okay? So A is equal to angle over 360 times pi r squared. So it'll be 290 over 360 times pi times 5 squared. Now, if you type this in exactly into your calculator, I end up with this 725 over 36, 725 pi over 36. And if you convert this to decimal, it'll be 63.27. Now, you got to be careful when you work with composite shapes and sectors, okay? So just be mindful as to what you're using and when you're finding the areas. So in my example here, I need to find the area shaded in blue, okay? The area shaded in blue is what we want, okay? Now I can, just looking at like these dotted lines here, I can pretty much add these in and turn it into a rectangle. So A is equal to L times W, which equals to 20 times 10, which equals to 200 millimeters squared. So that's actually the area of blue plus unshaded, okay? That's what this is, okay? Now you want to find the area that's unshaded now. So the area that's not shaded is in fact a sector, okay? Now, you don't even need to use the formula of a sector for this. We can tell that this is actually a quarter circle. So we already know the formula for a quarter circle. It's just pi r squared over 4. Okay. So if we just substitute our values in, so pi r squared, now you don't know what radius is, but you actually do. Because if you look here, on the left side, I have 10 millimeters. That means on the right side of the rectangle, that also is equal to 10 millimeters. And this is actually our radius, okay? So we're just going to use 10 as our radius now. We'll end up with 25 pi. If I type this exactly, so pi times 10 squared over 4, getting 25 pi. And if I change that to decimal form, it's 78.54. 54 millimeters squared, just like that. So that's the area of the unshaded. Now to find the area of shaded, you would use the area of the rectangle minus the area of the non-shaded area, 78.54. And that would equal to 121.46. So this would be our final answer, okay? Now, prisms, there are some key features here that you need to know, okay? They need to have two identical bases. For the sides, they must be rectangles or parallelograms. Now, parallelograms are just four-sided shapes, and they must have the same cross section all along from top to bottom, okay? Now, if you don't know what a cross section is, a cross section is the shape you get when you cut straight through a 3D object, okay? So it's so if you look at my example here, I have a cube. That green shaded area is where I make the cut. As you can see, it's a square, okay? Now, to identify as a prism, it must be the same from top to bottom, okay? That cross section, that shape you make, it must be the same exact shape, okay? Um, this is just like an image that I drew from the internet. So say for example, if I make a cut here and here, um, fix this one up so it looks like more like the picture. It'll look more like that, I believe. So the shape that it makes once I cut into it is actually a it's actually a rectangle right there, okay? Well, you sort of get the gist of it, okay? You don't need to know how to do this. You can just skip this one. Not really important. Um, how to name them. So the name of a prism comes from the shape of its base. For example, a triangular prism has triangle bases. Rectangular prism has a rectangle base. Okay, pretty obvious. Now, total surface area is what you need to know as well. Reference sheet, especially the two formulas here. So this is the formula to find the total surface area of a cube and a rectangular prism. All you need to do is just substitute the numbers into these formulas here and you'll be perfectly fine. So in my example here, find the surface area of these prisms. Now, this is not a cube or a rectangle. This is a triangular prism. Now, just remember the total surface area is when you add up all the areas in the faces, okay? So you need to find the area of the triangle. You need to find the area of the rectangle on the bottom. okay, you need to find the other area of the rectangle on the side, and then you got another rectangle in the back. Now, I will label these just to make sense. So my triangles here, I have 8 and 6 centimeters over there. For this first rectangle, I'm talking about 6 and 15. So this is the bottom. Now for my second rectangle, this is going to be the rectangle on the side, close to us, like from our perspective. And then the final rectangle will be the back, which is going to be 8 by 15, just like that. Okay. And it's going to calculate the areas of all of these shapes according to the measurement given. Okay. So the area of a triangle is base times height divided by 2. That equals to 8 times 6 over 2, which equals to 24. Now, have you noticed that there are actually two triangles? So you got the one in the front and you also got the one in the back. Okay. So once you find the area of one triangle, multiply it by 2 now. So your new measurement for your new area for the two triangles is actually 48 centimeters squared. Okay. Now this is pretty obvious. Length times width, 6 times 15, that equals to 90. This is for the side, 15 times 10, which equals to 150 centimeters squared. And then the last triangle is 15 times 8, which is 120 centimeters squared. Okay. Now the final step is to add it all up. So you got 48 plus 90 plus 150 plus 120. And if you type this all into a calculator, end up with 408. So my total surface area is 408 centimeters squared. Okay. Capacity. Okay. Now, capacity is just the volume of a liquid or gas in a container. Now, this container can be just any 3D object. Doesn't matter. Okay. Provided that, you have the formula to work with it. Okay. You need to know how to convert this as well. So reference sheet, this flowchart, you need to know all of this. Okay, so specifically this one and that one right there. So 1 milliliter is the equivalent to 1 centimeter cube. You should know the second one already. 1 liter is 1000 milliliters. And the last one is 1 kiloliter is the same as 1000 liters, which is the same thing as 1 meter cubed. Okay. This is something you may need. Okay. Volume for um, a rectangular prism. It's just length times width times height. For a cube, it's length times length times length. Okay. And here's an example. So I know this is a rectangular prism, so I'm just going to write out my formula. And then I just substitute whatever numbers are in there. So 6 times 4 times 2, which ends up being 48 meters cubed. Now, whenever you're dealing with volume, okay, you must always have it in cubed. That's the most important thing. And just remember, volume is measured in these ones right here. So cubic millimeters, cubic centimeters, cubic meters, cubic kilometers, okay? Pretty straightforward. So just remember volume cubed. For capacity, okay, it's pretty straightforward. So I just have like these little hints on the side. Make sure you use them. It's pretty obvious, okay? So find the capacity in liters when you have a rectangular prism, and then you have all these measurements here. So 25 centimeters long, 15 centimeters wide, 18 centimeters high. Just start off by finding the volume of the rectangular prism. It's pretty obvious, 25 times 15 times 18. If you type all of this in your calculator, you get 6,750. Okay. This is in centimeters cubed. Now the next step is to convert, okay? Convert to capacity. And now you know that 1 milliliter is the same as 1 centimeter cube. So this means that this will end up being 6,750 milliliters. And to convert to liters now, you just go 6,750 divided by, let's see, to go from milliliters to liters, I need to divide by 1,000. So this will end up being 6.75 liters. Okay. All right, volume of a prism. This is for any general prism. And it's pretty easy, okay? So all you need to do is find the area of a cross section and multiply it by the height. What this means is just find the area of base, okay? That's all it means, which is the shaded. Once you find the area of that shaded shape, you can just multiply it by its height and you use this formula right here. Okay, very important. So finding volumes of prisms. So I'm just going to write V is equal to A times H. Now in my diagram, I can see that the shaded area is already given to us, which is 10 centimeters squared. I'm just going to multiply by the height. This ends up being 30 centimeters cubed. Okay. Now in this triangle here, this triangular prism here, I need to find the area of a triangle. Okay. So why don't I just draw out the shape just to make life a bit easier. So this is going to be 4 meters. If I draw a dotted line down here, that's 2 meters. Find the area of a triangle. Just ends up being base times height divided by 2. We know what the base is. The base is 4, the height is 2. Do all of that, type in the calculator, you get 4 meters squared, okay? Now to find the volume, I need to multiply this by 8 meters here. So it now becomes 4 times 8, which ends up being 32, not centimeters, but meters cubed. See, pretty straightforward. Last thing you need to know is a volume of a cylinder, okay? So, very important. This is the formula that you would use here. V is equal to pi r squared h, which is the same thing as that one, okay? The second one is what you would rely on more. Now, in this example, I have a cylinder round to 2 decimal places. So I'm given the cylinder with the radius being 2, my height being 10. So just start off by writing out the formula, name pi 2 squared times 10. This ends up being 40 pi. And if you type it in your calculator, 40 pi ends up being 125.66 centimeters cubed. Now, in my second example here, I have here a diameter of 14 meters, as you can tell, based on the line markings, and a height of 20 meters. So, but we need the radius of the circle. So to find the radius, we just take the diameter divided by 2. So 14 divided by 2 is 7. And now we can just find the volume of the cylinder by using our formula. So pi 7 squared 20. So pi 7 squared 20. That equals to 980 pi, which is the equivalent to 3078.76 meters cubed. Okay, so this is everything you need to know for chapter 4. Okay, so please make sure you study hard, go through chapter reviews. Okay, so do chapter review. I think it's question 1 to 7. Just have a look. Just go based off from chapter 4A all the way to 4I. Okay, take care.